A window has the shape of a parabola above and a circular arc below. We're going to find the area of the window. So the last part of this question is where we're going to find the area of the window. So in order to do that, we need to find a function for the top part of the window, and then a function for the bottom border of that window, so that when we integrate, we can find the difference between the two. So the first things we need to do is we need to find equations for both of those lines. Now, we also are asked in this question, one of the parts is to find the distance from the x-axis, which is this here, up to the top part of the circle. So we need to find this distance here. Once we get the equation of the circle, which is this part here, and if I draw the whole thing so you can imagine it, if I can draw a nice circle, it doesn't look real smooth, but this will be the center and this will be the top of the circle. And one of the parts of the question is to find the distance from here to here. Once we find the equation of this circle, then what we can do is we can find the value of y when x is 0. That will give us two values. That will give us this value here and this value here when x is 0. And we'll just know that we use this value up here because we're looking at the top hemisphere of the circle. Okay, so to start off, let's find the equation of the circle. And if we think back to our algebra and our trig class, the general formula for a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. H and k are the parts of the center. So h is the x coordinate of the center and k is the y coordinate of the center. So that's this right here. This point right here will be h comma k. Now, we only know what this point is here for the x value. We know that the x value is 0 because it lies along the y-axis. So I labeled that here. We know what h is. H is 0. We don't know what k is. We don't know how far down this is from the x-axis. We do know, based on the picture that's given to us, that the radius is 11. So I marked that here. And we also know two of the points. We know this point here, and we know this point here on the circle. And I know these 2 points because this information is given to us. This is saying from here to here is a distance of 13.3. Because of symmetry and the way this is set up, if I divide that in 2, it will help me figure out what these 2 points are. So when I take 13.3 and I divide it by 2, I know that this point right here on the right is 6.65 comma 0. And this point over here on the left is negative 6.65 comma 0. So I also know that, and I labeled it here. And we're going to use all this information to find k, because I have all the other information I need to set up my general form of the equation. I need my h, I need my k, and I need my r. So we're going to use this extra point that we have on the circle to solve for k. Now, when we solve for k, and remember what k is the y coordinate of the center for the circle. So when we solve for k, we have to take the square root of both sides. And so when I do that, I get k is plus or minus 8 plus 7623. So I need to make sure that I'm looking at the negative value of this because of where my center is located. My center is located below the x-axis, so I know my k should be negative. When I plug that into my general form of the equation, because there's a negative in my formula already, and because k is negative, I'm going to end up getting a double negative in my formula, and it's going to turn into a plus. So my equation for the circle is x minus 0 squared plus y plus 8.72623 squared is equal to 121, which is our radius squared. Now, to find the distance from the x-axis to the top of the circle, we're going to use this equation. I'm going to solve this equation for y. And when I do that, I'm going to get y is equal to plus or minus the square root of 121 minus x squared. And then outside the square root is minus 8.723. Now, which one do we use, the plus or the minus square root? Because the question is focusing on the top part of the circle, or the northern hemisphere of the circle, we're going to use the positive square root. So my final equation, when I write it in terms of y, is going to be positive square root of 121 minus x squared minus 8.723. What that does is that gives us the equation, whoops, I'm not really lining this up very good. It's going to give us the equation for this part of the circle, the semicircle from here to here. The negative square root will give me the bottom half of the circle, what that formula is. Okay, now to find this distance, that will be the value of y when x is 0. So I'm going to plug in 0 into this equation, and I'm going to get y is equal to 2.23. It got cut off, but it should be 7.7. Now we need to find the equation of a parabola. And so in general, we know that this is the equation of our parabola. If we think back of our conic sections, we have x minus h, quantity squared, is equal to some constant times y minus k. Now, in this question, the h and the k is the vertex as usual. Now, we know what the vertex is because that's given to us in the question. The vertex for the x-coordinate, or our h, is going to be 0. And then this tells us that the height is going to be 4.11. So this is our vertex. We know what that is. We also know another point on the graph, which we used in the circle too. Both the circle and the parabola have this point in common. We have 6.650. That's this point right here. And we're going to put all that information in so we can find c. Because in order to find the equation of the parabola, I need to know my h, my k, and I need to know this constant that goes in front. So I'm going to put all the information in. I'm going to solve for c, and I'm going to get that c is negative 10.7599. So now when I put this all together, I get that this is my equation of the parabola. X squared is equal to negative 10.7599, and then inside the parentheses, y minus 4.11. Now, in order to find the area of the window, which is the last part, but actually the main part of this question, this is what we've been working up to. We need to take the equation that we got for our parabola and subtract it from the area that we got from our semicircle. But we have to have it solved for y in order to be able to do this. So we already have the circle solved for y. We have that up here. And then when I solve this for y, I get this here. So this is my parabola rewritten in terms of x. So it's y equals and then all of this. Now, because I know that my area goes from negative 6.65 all the way to positive 6.65, that is going to be the limits of my integration. And then I'm going to take my first function, my parabola, minus my second function of my parabola, and I'm going to integrate. Now, I'll let you guys do that on your own since this is what you're practicing, but at least hopefully this will help you figure out how to set all this up. Now, one last thing, we could have gone from 0 to 6.65. Since this is symmetric, I could take just this area and double it. So that's another way that you can do it if you prefer to do it without using negative limits. Hopefully this helped.